Okay, so yesterday we did learn how the shortcut to use in the calculator to solve systems of equations rather than graphing by hand. Of course, it is important to learn to graph by hand because we'll need to know that next semester. But let's get started here. So first we make sure it's in slope-intercept form. So number one, they both are. So what I do in my calculator is I go to y equals and I type both equations in. So this first one is x plus 4. The second one is 5 over 2x plus 4. You hit graph. Oops. Let it load. Sorry. Okay, so you let it load. There should be 2 lines, and you should be able to see where they intersect. And if I do, then I do second trace 5, enter, enter, enter. My point of intersection is given at the bottom of my screen, so this point of intersection is 0, 4. Okay. Number 2, the second one is in slope-intercept form, but the first one is not. So I need to subtract 4x first. So 3y equals negative 4x plus 13. Divide by 3. This one's not going to be very pretty, but we can do it. Negative 4 over 3 is negative 4 over 3x. And 13 over 3 actually does not simplify, so we're going to leave it 13 over 3. So then I can type both into my calculator. So this is when the calculator is really nice because they don't always come out so perfect. So this one, we're going to do negative 4 over 3x plus 13 over 3. Then hit graph. As long as you do the converting correctly, we should get the correct answer. So you see the blue line, then you see the red. Ooh. So this one, you can see the intersection at the very top left corner. Okay, then I can do second trace 5, enter, enter, enter. And my point of intersection does happen to be a decimal here. So my point of intersection is negative 3.59. And the main reason is because of that fraction on the y-intercept. So this is where the calculator does come in handy. Number 3, they're both in standard form, so we need to convert both. So we're going to subtract x on this first one. Y equals negative x plus 10. The second one, we're going to subtract 3x first. So 5y equals negative 3x plus 38. Divide both sides by 5. And this is going to be another one where it does not come out to a perfect answer, because 38 over 5 doesn't simplify more than that, so it's just 38 over 5. So then we are going to type that in our calculator. So the first one was negative x plus 10. The second one was negative 3 over 5, x plus 38 over 5. Hit graph. Let it load. There's the blue one. There's the red one coming in nice and slow. Once you see the loading circle done, you go second trace 5, enter, enter, enter. And my point of intersection actually does come out pretty, even though my equations weren't perfect. It comes out to 6, 4, so that did get pretty good answer. Number 4, same thing, we're going to convert. So the first thing I do on the first one is subtract 7x. So I have 6y equals negative 7x plus 4. Divide everything by 6. So y equals negative 7 over 6x. 4 over 6 simplifies to 2/3. So that one came out to another fraction. This one I'm going to subtract 4x. So I have 6y equals negative 4x plus 19. Divide by 6. So y equals negative 4 over 6 simplifies to negative 2 over 3. And 19 over 6 does not simplify past that, so it's just 19 over 6. Then we type it into y equals. So I go, oh my gosh, negative 7 over 6 x plus 2 over 3. The second one is negative 2 over 3x plus 19 over 6. Okay, let it load. Give it some time. Sometimes it does take a little longer. This one I can see the intersection, so once it's done loading, given by the circle at the top of your screen, then I can do second trace 5, enter, enter, enter. when I see the word intersection, so my answer does come out to a decimal. -5 and 6.5 is my solution. 2 more, so number 5. First thing I do is subtract 7x, so I have 7y equals -7x plus 28. Divide everything by 7, so y equals -1x plus 4. The second one, I subtract 7x also, so I have 10y equals -7x plus 22. Divide everything by 10, so y equals 7 over 10 does -7 over 10 does not simplify, but 22 over 10 simplifies to 11 over 5. Once I type both in, so -1x plus 4 and -7 over 10x plus 11 over 5, hit graph. That one came out faster. I think when we're dealing with fractions, it just goes a little bit slower. I can see where they intersect. So once it's done loading, second trace 5, enter, enter, enter. My point of intersection is a pretty number, 6, -2. And last but not least, number 6, I solve for y, so I'm going to subtract 3x first. So I have -4y equals -3x minus 10, divide by -4. So y equals -3 over -4 is 3 over 4, and -10 over -4 simplifies to +5 over 2. The second one, if I want to solve for x, it's in a weird order, so I'm actually going to subtract 3x. So I have -3x minus 13, divide by -4. So y equals -3 over -4 is +3 over 4. And -13 over -4 simplifies to +13 over 4. So not the prettiest of fractions. But if I trust my math and I type my calculator, okay. You could probably already predict what you're going to see because of my equations I ended up with. They both had the same slope, different y-intercepts, so they weren't exactly the same. If you look very closely, okay, it looks like they almost squeezed together, but these equations would actually be parallel. When they are parallel, that type of equation, that solution is called no solution because they will never intersect. Remember, the third type is when they are exactly the same equation. That means they are infinite solution or all reals.